Hello GameMakers, this is GameMaker Rob, and in today's episode we have a tutorial for the diablo-style inventory. You can have as many containers in a room as you like. You can pick up, drop, rotate items. Items fall to the player's feet if dropped, and you can have containers spawn items when they are created, and they'll automatically try and fill themselves with those items intelligently. And also designed it to make saving the inventories easy for persistence between games. Okay, so I'm going to go through the setup for the room and for the sprites before we get into the code. So for the room, the width and height doesn't really matter too much. For me, it's 1200 by 800. We've got a viewport. And the size of the camera and the viewport is 640 by 480. I've also set my XPOS and YPOS as 160 by 300. This is just to kind of simulate the player not being in the top left portion, just to make sure that the code works regardless of where the player is in the room, because we want the inventory to show, regardless of the player's position. We want items to drop to the player's feet when they drop an item. We have a background sprite. I've just put in this bit here, so chose the background sprite for this. I've had it stretch across just so I don't have a black background. That's the only reason for that. This is that background sprite, 1100 by 620. We have a player sprite, 32 by 64. The only reason I've got this is so we can see a player in the room. Wherever the player object is, that's where the items are going to drop. Cell. So this is a size of 16 by 16. 16 is going to be our tile size. It's going to be used for plenty of calculations. We have two indexes. We have an index to show that it's not highlighted and an index to show that it is highlighted. Containers, so we have sprites for a container inside the room, which is what this one is for. It's for the chest. Whenever you see an R underscore for the containers, that means it's going to be for the room. SBR underscore con for the chest and for the inventory. These are the sprites that actually display the items that we move around and that kind of thing. So we've got one for the chest when the chest is opened, and again there's two indexes. The first index is when it's not the highlighted inventory, and the second is for when it is the highlighted inventory. There's only ever going to be one inventory highlighted at a time. And the same for SBR con inventory. This is the player's inventory. It's 360 by 360. There's two indexes. One thing that I forgot to show you for the chest sprite, it's 200 by 120. The size, the width and height matters for this stuff. For every container, for the code to work the same, we want a 20 pixel buffer from the top to the middle, left to the middle, right to the middle, bottom to middle, and this area here, alone needs to be in multiples of 16. So, for example, the width of this whole sprite is 200. If we take away 40 from it, because there's two lots of 20 on either side, that leaves us with 160, which means we've got 10 grid tiles across. 160 divided by 16 is 10. And then for the height, 120 take away 40 is 80, which is 5 tiles. So we have 5 tiles upwards and 10 tiles across. That's the size of this inventory. Same thing for the player's inventory. Whenever you want to work out how big a sprite should be for the inventory, you just take away 40, or you start with 40 for the width and for the height, and then you add a multiple of 16 to it, and that's going to be your width, that's going to be your height. So then items, these sprites are going to be for what we see inside the containers. For items where for items like this, like a circle, we don't need a rotated version, so I just have one sprite for the shield. Again, they want the size, the width and height want to be in multiples of 16, so they fit nicely into a grid. The origin is in the top left for these as well, for the sprites. For the containers, the origin is also in the top left. Everything has a top left origin. For things like the spear, we have a sprite of 128 by 16, so it's a lot wider than it is taller. If we want to rotate it, then we're going to use this sprite here, so it's the same dimensions but reversed. So instead of 128 by 16, it's 16 by 128. And to make it easier to identify, I just added _R, meaning rotation. Not to be confused with this one, SPR_R, which means a room. Hopefully it's not too confusing. And then we have items for the floor. So for every item, we're going to want at least one sprite for going into the inventories, and then another item for how it looks on the floor. These sprites are a lot smaller, so for the shield it's 16 by 8, for the spear 42 by 6, and for the sword 24 by 6, and that's it. That's all the sprites. Okay, so we're going to have an object called Obj main. Let me just show you the different layers we have. Okay, so we have the background layer, we have containers. This is where all the containers are going to be. Active container, we're going to use this to decide whether a container is going to be drawn on top of the rest of them. And mouse is going to be where we display the mouse object. So we're going to, if the player's holding something with a mouse, we're going to display the item there. And we're also going to have Obj main, our first object. We're going to have that inside this layer. So each of these are instance layers, and we want to have it in this order. So make sure you've got these layers. Make an object called Obj main and put it into the room. I've got mine over here like that. And Obj main, do we need it to be persistent? I think we should, yeah. So let's make Obj main persistent, and then in the create event, so we have a tile size of 16. Like I said, 16 is our favorite number in this tutorial. We're going to use it to determine lots of things, so we're going to be using it a lot. Global.canPlace, so like it says here, can the item be placed in the current global active container? This is going to be set to true or false, based on whether there's space for the current item where it is in the inventory. Mouse sprite is going to be -1 if there's nothing to be shown, and 0 or higher if it's a sprite of something like a weapon, like a shield or spear or something. Item type is just going to be like it says here. We're going to have an enumerator. You'll see that in a minute. The enumerator is going to be called eItems, this one here. An item type is going to equal either a shield, spear, sword, or whatever else you have in here. Rotated, this is going to be set, it can be set in two ways. It's either going to be set when the player presses R to rotate an item, and if it's rotated, then it's going to be using one of these sprites, usually ending in R. Also, if a rotated item is placed into the inventory and then the player picks it up, global.rotated is going to be set to true again, just to let the game know that yes, this sprite is rotated. So that's the two ways this is going to be set to true or false. Active container. So this is going to hold the instance ID of a container. Whatever container is active, that's the one that is going to have items placed into it. That's the one that's going to be displayed on top of everything else. Global.moving, we only want to be able to move one container at a time. So the ID of which container is being moved is going to be stored in this as well. It's going to be separate to active container. So we have a new region, setup sprites. Each item is going to have 3 different entries. We have a 2D array. That's what this is about. So the first entry in our 2D array is what item is it. So we have shield, spear, sword. The second entry, so 0 is what sprite should be used for this item for the inventory. If the sprite is not rotated, so for the shield, if it's not rotated, it's going to be SPR shield. This second one, if the sprite is rotated, what sprite to use? For the shield, it's the same one. For the spear and for the sword, we're using the rotated versions. And then finally, we have a floor sprite for this item. So when it's on the floor, what sprite should be used? So SBR F shield, SBR F spear, and SBR F sword. That is these items, the small ones. And then some information for the containers. So we only have 2 containers so far. We have the player's inventory, which we only want to have one of, and we have chests. We only have 1 chest in the game, but there's no reason why you can't have multiple chests. Again, we want to store the sprite to be used for each container type. So for the player's inventory, we have SBR con inventory, and for the chest, we want SBR con chest. The player's inventory only needs 1 sprite because you're never going to see it in the room, unless I guess you have like a backpack and you want to be able to unequip inventory. You could use that, but for this tutorial, the inventory is always with the player. You can't get rid of it. So, but for the chest, we want to display the chest in the room as well as when it's opened. So the sprite is for when the chest has been opened. SBR con chest. This one. And this one is for when it's in the room. I know I've already said this stuff. I just rather kind of reinforce it as we go. And then the last thing we're going to do in the create event is we're going to create an instance of our player's inventory, and we're going to create it on the containers layer, which is where all the containers should be when they are first created. We also want to have a step event for the main object. So just create the step event, and all we're going to do is whenever we press I, we're going to toggle our player's inventory active variable to true or false. So if it's false, it gets set to true. If it was true, it gets set to false. That easy. We also want to have a container object, obj container parent. This is going to do the vast majority of the work for all of our containers. So we're going to have 2 enumerators. We have econ states, so the state of the container, Not ready is the initial state, and then we're going to create a grid in the step event, do everything we need to, and then set it to ready, and that's when the container's able to do things. This enumerator is going to be for our lists. Every cell in every container, the grids of the containers, is going to hold a list. The list is going to know what sprite does it contain, the item type that it contains, is the item rotated, was it rotated when it was placed into the inventory, the index. This is going to be a unique number for every item. For example, if there were 2 swords, they would have different indexes. This is how I know, or how I let the game know, which cells are together. So what cells does the item cover? There's other ways to work it out, but it's just a quick way to say, okay, does this cell have the index of the item? That's all it's for. Relative x and y, these 2 variables are going to be used for when we're moving containers around. This is to make sure that the same distance between the mouse and the container are kept. I'll explain a bit more when we do that code. Image speed 0, we don't want the container to be switching between the indexes itself. Set the initial state to not ready, like I said. Active is not true to begin with. We have to press I to open it, and we want to initialize gx gy, which is just the mouse coordinates for the GUI layer, the draw GUI layer. All the containers are created, and well, not created, but they're displayed on the draw GUI layer. So it doesn't matter where the player is in the room. The inventories are always going to be displayed in the right place. So then in the step event of our container object, we've got a couple of things going on. So we've got the initial state that I was talking about when the container is not ready. This is when it's first created. It's going to have a grid. That's what this region is going to do. The sprite of the container depends on its con type. So we don't have a con type in the create event of the container objects, but we do in the inventory and the chest, because it's going to be dependent on what type of container it is. So don't worry if you get a yellow mark for this when you first type it, because we're going to set this afterwards. So SW and SH is going to be the width and height of the sprite, so whatever container it is. W and H are going to be the width and the height of the actual grid. So for example, if we have a grid of 16 by 10, width will be 16, height will be 10, and then we just create a grid based on that width and height. Then for every cell in our new grid for this container, we're going to create a list called data. We're going to use a script to set our list's data to default information, and then save that list to our grid. We will get to this script in a minute. Then after we've done this stuff, set our state to ready, and that's the end of the region. So if we make a new script and we call it scr reset data, it's a really small script. We're passing it the pointer of the list, which will be a number, and then we just use a for loop to go from 0 to the end of the data enumerator, and we're just setting everything to -1 in that list. That's all we're doing. So that's the end of this region. Otherwise, if state is ready, then this stuff is going to run, and also if it's active as well. So if it's active and it's ready, we want to track the mouse on the draw GUI layer. That's what this is going to be doing in the step event. This region here is the mouse within the margin of this container? Whenever the player has the mouse in the margin and they click and hold the left mouse button, they're going to be able to move it around. So we need to work out, well, are they actually within the margin? So that's what this region is going to do. So the first thing we do is set within margin to false. And then this code here is checking whether the mouse is within the top or bottom margin of the sprite. And we're going to have a little show debug message to let us know that yes, it is within the top or bottom. I'll run the game in a minute and show this working. And then we have the same thing for the left or right margin. Just a little bit different. Make sure you get the brackets down. That's important. So these first two checks are within one pair of brackets, and then the closing bracket for this one is over here. So all this stuff is within those brackets. Then we have this pair of brackets and the rest of them, or this pair of brackets. Pretty easy to see. And the same for this. So here's the first pair. Here's the next pair. Encompasses all of this. This pair. And this pair. And this pair. So that's this region. Then if within margin is true, does the player want to move this container? Let me just move this to the next line so I can zoom in a bit more. Okay, so this is this region. Does the player want to move the container? If there is nothing set inside global.moving, if it's set to no one, and we press the left mouse button, and we're not holding anything with the mouse, then and only then is it okay to set the ID of this container to global.moving. This is when we set relative x and y to the GUI x and y minus the display x and y. The display x and y, if you remember, is the coordinate of where the container is being drawn from. So it's the top left of the container. So relative x and relative y are going to be the difference between gx and gy and display x and display y. Just so we can, it helps to, if we don't have this, then the container is just going to jump to where the mouse is, which is not what I want. It looks a bit silly as well. So, and this message is going to tell us that it's working basically. Let's close this region. And then finally, move the container. So if global.moving equals this ID, so there's only going to be one container that this is going to be true for. If we let go of the mouse, then we want to reset global.moving because we're done moving. Otherwise, we're just going to set display x and y to gx minus relative x and gy minus relative y. So let's just minimize these regions again. I'll zoom out for you as well. So this is what the step event looks like so far. Okay, so now we're going to do the draw event for container parent. Just maximize this. So this one here is going to draw the sprite that's assigned to the container, which will be the room sprite. For the player inventory, as you can see, there's no sprite assigned to it. So this isn't going to run for our inventory, but it is going to run for the chest. I just figured we'd add it in for now. And then for the draw GUI, so if it's active, we're going to be doing all of this stuff. Just going to zoom out for a minute. There we go. So if it's active, all this is going to happen. we're going to draw the relevant container sprite for this container with the relevant image index, which is going to be either 0 or 1 at the relevant coordinates, which is going to be the top left. And the first thing we're going to do is draw our cells for this grid's container, or sorry, for this container's grid, which is all of this region here. Let's just minimize it a little bit. Zoom out, I mean. Okay, so first thing we'll do is we'll get the draw x and draw y. Display x plus 20 because of the margin. Display y plus 20 because of the margin. That's going to give us the top left of our grid. If global.place is true, then we're going to draw this cell as white, otherwise we're going to draw it as red. So where is the mouse or mouse sprite in relation to this container's inventory? We need a diagram for this. Okay, so I've got a little diagram to explain what's going on. So we have our player inventory. This is where it's being drawn from, the display x and y. X, when we're doing a double for loop, we're drawing from here to here, and then from here to here, from here to here, exactly, etc. Going across is the XX, and going down is the YY. And here, for example, we've got a mouse item, which is like a small shield, like it has, it's going to be a 32 by 32, which means we have 2 horizontal cells for this sprite and 2 vertical cells for this sprite. And when we're moving the item over, it's never usually going to exactly fit our grid like this. It's going to be usually something like this, and the player wants to drop it, and then into this area it will go. So when we're doing these checks, like here, if XX is greater than or equal to cell X, so at the moment when XX is 3, it's never going to be greater than or equal to cell X. But if we move the mouse item over here, then all from 0 to 2, or from 0 to 3, they're all going to be greater than or equal to cell X. And then we have here as well, XX has to be less than cell X plus X cells. So when we move the mouse item here, cell X is going to be 0. You add 2 to it, which gives us 2. So XX has to be between 0 and 1 for it to be highlighted. So, for example, any cells here on the x-axis, and we do the same check for y, for the y-axis. So, for example, if mouse item was here, then I'm going to shade in all the affected cells. So all of these would be highlighted. If we had the mouse item here, like there, then these cells would be highlighted. And that's how we do it. That's how it's going to work. So if it's within that range, then yes, it's highlighted. Otherwise, highlighted is going to be false or 0. It's the same thing. Then we're just going to draw each cell. We're going to use highlight to determine the index 0 or 1. Draw it at these coordinates. Scale is going to be 1. Rotation is going to be 0. Col is going to be the color that we set. Where is col? Oh, there it is. That we set here. And then alpha is going to be 1. So remember, highlight is going to give us either this image for 0 or this image for 1. That's what it's for. Sorry. There we go. That's the end of that region. Okay, so we're going to use a second double for loop to draw items. So same draw coordinates. This time we're going to get the value of SPR. This isn't going to make complete sense right now because we're not adding anything to the grid, but I thought might as well get this code in now. The way it's going to work is when you place an item down, only one of the affected cells is going to have SPR set. It's going to be the top left one. So only if we go back to our sheet, if we place something here, only this cell is going to be drawing an item. So if sprite is greater than or equal to 0, that means it wants to draw something. So we're going to draw the sprite like that. And that's it for the draw GUI for now. So now that we've done this, we're going to go into Obj Inventory. The first thing we should do is set the parent of this object to obj container parent. That, there we go. And then we have a create event for the inventory. Well, when you add it as a parent, you should get all of these different events being inherited from it. But we want to make a small change or a small addition in the create event. So make sure you add a create event, and then inside it, we need to type event inherited so we can get all the information from the parent. And also, we're going to set our con type as inventory, and also the initial display in X and Y value is going to be calculated here as well. And that's it. If we run our game now, we're going to be able to move our inventory around. So press I, we can show and hide the inventory. If we click anywhere in the margin and hold the mouse, we can move it around. If we release it, nothing happens anymore. You can see in the bottom where it says output, you can see every time we move it over a margin, it tells us in the output, yes, it's within the margin. If I click and hold as well, we'll get this message. Global moving set to 100,002, like that. It's just making sure our code's working, and the way it should work is if you click in one of the margin areas, you can move it around as much as you want. If you let go of the mouse, the inventory no longer follows the mouse. If you try and click inside the grid, nothing happens. You have to click in the margin like that. Okay, so now we're going to add some items to the room. We're going to be able to pick them up and drop them into the inventory. So for this, we need to add 4 more objects. We've got obj par item, which is going to be the parent of everything. We have obj shield, obj spear, and obj sword. Make sure that you set the parent for these 3 items as obj par item. I've already done it for the shield. Par item. Okay, so 3 item objects. They have the same parent, which is obj par item. In the create event of par item, we just have this one line. It's just really a default, just in case we forget to overwrite it. It's just setting the rotated sprite as sprite index. For example, for the shield is going to have the same rotated sprite, but for this sword and spear, this is going to get overwritten. Then in the step event, we're just going to check to see if the room mouse coordinates are within the boundary or collision mask of the sprite. That's what this check is for. So if it is, then mouse is over the item. Then if we press the left mouse button and there's nothing being held by the mouse already, then it's okay to pick up this item. So what's going to happen is we're going to set the mouse sprite as the item sprite, but it's going to be the item sprite that goes into the inventory, not the one that was on the floor. That's why we grab it from here. And then we're setting global.item type as the item type, so e.g. items.sword, which is 2 or something, or 1. So that's what item type is going to equal. And then we get rid of the item. We just destroy it because we don't need it anymore. So that's the step event for power item. And then for the draw, we're going to draw itself, and then this is for the actual room as well. If the mouse is over it, then want to highlight it. So we're going to set a color of white and then draw a rectangle over the sprite. And we're going to make it an outline just to kind of highlight it. And then in the shield object, in the crate, we're just going to inherit the event. We're not going to overwrite rotated sprite, but we are going to say this particular item type is a shield. Then for the spear, make a crate event, we're going to overwrite rotated sprite, and we're going to set item type as spear. And for the sword, same thing, set the rotated sprite as sword, item type as sword. Job done. If we go into the room now and just place some items, see I've got some items just dropped on the floor here. They're in the containers layer, so you just grab a shield, for example, or a spear, just drop it wherever. So this is kind of about the area where the player is going to be. So I'm just placing it there for now. So going to Obj main, we're going to have a new event, the draw GUI, and here we're going to say, okay, if there is a mouse sprite, then we want to draw it. If we can place the object, then we're going to draw it with white. Otherwise, we're going to draw it in red. MX, let's change it to GX and GY, are going to be the draw GUI coordinates. And then we're just going to simply draw the mouse sprite like this. Col is going to either leave it alone or draw it in red. It's dead easy. If we run the game now, I do have a bit more code to show, but I think if we just test it, that you can mouse over an item and it should highlight. We should have like a white rectangle over it like this. And if we click on it, then we have a mouse item as well. We can no longer click on any other item because we already have a mouse item, but you should be up to this stage right now. So now we're going to do some heavy work in the create event of obj container parent. We're going to have a new variable called total items. What this is for is just so we can distinguish between what cells belong to what item. It's an easy way to do that. Every time you add an item to a grid, total items increases by 1. So if you add a shield and it's the first item, then every cell under that shield is going to equal 0 for its index. When you add the next shield or a spear or something, it doesn't matter what, then every cell under that item is going to equal 1 because we've increased it by 1. You'll see what I mean when we get to the code, which is mainly in the step of the container object. Let's just zoom out for a minute. So we're going to comment out these 2 lines, but you can copy them because we're going to use it in this region here. So this region is going to make this container the active container. So we're going to move these 2 lines to here. We're going to determine the left, top, right and bottom of the inventory. These are basically let's show. It's this. So inventory left is going to be like this line here. That's inv left. Inv top is going to be here. Inv right is here. Inv bottom is here. So we're just determining those coordinates in this bit. Let's zoom in, sorry. So is the mouse within the grid of this container? If the GUI X and GUI right is within those coordinates, then yes, it is within the inventory. Basically, anywhere in this region here, then it will turn up as true. And then we want to set this current container as the active container. So all we're going to say is, okay, if the container is no one, then set the container, the active one, as this container. Otherwise, if the mouse is outside this area, so like here or here somewhere, as long as it's not within this grid, then we're going to do a check. If the active container is this container, then we're going to set the active container as no one. And then we're going to say no, the mouse is no longer within the inventory. That's what that region's for. And then we have another region. This is going to be doing the heavy work of checking whether we can place an item, whether there's something blocking it, whether it fits in the grid, that kind of stuff. So there's quite a lot of code in this region, but we'll get through it now. Okay, so this is the whole region. We have like 4 separate bits to it. This is the first section. This will be the second, third, and fourth. So the first thing we want to do is, first of all, do we have a mouse sprite? Second of all, is this container the active container? Third of all, is the mouse within the bounds of the inventory? So there's 3 things you want to check. If all of those are true, then all of this stuff can happen. Start X, start Y, end X, end Y are going to be basically this is turning out to be really useful, this diagram. So this is start X, start Y, and this is, let's do a circle. So this is start X, start Y, and this is end X, end Y. So no matter where we're moving this around in the room, start X, start Y, end X, end Y are changing, and we're using those coordinates to check where it is relative to the grid. That's what it's about. So this next region is the mouse within the bounds of the container's inventory. If it's not, then we're not going to be able to place the item. So let's open the region. This is the region in its entirety. So we're going to say, yes, okay, we can place the item. And then depending on whether this is true or false, we're going to set global.com place to false. Basically, if start X is less than 0, then we can't place it. If start Y is less than 0, then we can't place it. If start X is greater than or equal to the width of the grid, then we can't place it because it's here somewhere. If start Y is greater than or equal to height, then it's going to be down here somewhere. If any one of these conditions are true, then no, we can't place it basically, and we'll get a little message in our output to tell us that as well. So that's the first region. The second region is the mouse sprite also not overlapping an existing item. So we could have like items here, here, and here, and then when we're moving our mouse item around, we're looking for a space where we can place it. So all of this area would be a no-go. This would be a no-go, but here, in here, would be fine because it fits there. So this is the whole region. So if after this region, if global.camPlace is still true, then we're going to do this check. We're going to check several cells, starting at start Y and start X, ending at end Y and end X. If any of these cells has a sprite index not equal to -1, basically, that means there's already an item in at least one of the cells. So then we're going to set camPlace to false, and we're going to break out of this loop. So that means this isn't going to happen, this last region. Okay, so this last region here adds the item to the inventory. So if we release the mouse button and we can place an item, we've done all the checks we need to. So we're going to have a message to show we can place the item. We're going to increase total items by 1. We're going to go through a double for loop where the XX starts at the start X, which is determined by where the mouse is, and the YY starts at the YY. We're going to grab the list for this cell from the grid. The list is called data. This check here, if we are at the very top left of where we're trying to place the item, then XX will equal start X and YY will equal start Y. We want to set the sprite entry for the list as the actual sprite that we're placing, because we're going to be drawing the item in the grid from this cell. Otherwise, for any other part of this double for loop, we're just going to set the sprite entry of the list to -2. So it's letting us know, yes, there's an item there, but no, we don't want to draw it. Then for every list, we set the item type, the rotation, and the index. And then after we've done this double for loop, we reset the mouse sprite, we reset rotated, and we reset the active container. So let's just minimize that. Okay, so now if we run the game, we should be able to see this happening. All the hard work that we've done so far. So we press I to open the inventory, move it around. We click on a shield. We don't have to hold it right now because we're not doing dropping yet. But if I move it over the grid, you can see the color of it changes if it's within the right area. And if I try and place it anywhere where it covers enough cells, then it'll get placed. Same for the spear, although I released it a bit too quickly then. So if I try and place a sword on top of a spear, it shouldn't work. But as soon as the cells turn white, then yes, I can place it. Okay, so now we're going to have a player object. Doesn't have any events. We're just giving him the player sprite, and we're putting him in the room there because now we're going to have objects being dropped. So all that's going to happen is an item's going to fall wherever the mouse is. It's going to fall until it reaches the player's Y, which is here. I have the sprite at the bottom center. Yeah, bottom center, which is here. That's where the items are going to fall roundabout. So then if we go to the OBJ main step, we have a new area here. So the first thing we want to do is, do we have an item in a mouse? If we do, then did we just release the left mouse button, and are we not able to place it somewhere? So let's show a message to say we're dropping the item. We're going to create a new instance of obj power item at the mouse X and Y on the active container layer, and then with the item we're going to give it the global item type. So if we're holding a spear, we're going to set item type as a spear. That's how we're going to know how to set the sprite index. We can just put item type here instead. Doesn't make a difference, it's the same thing. After that, we clear the mouse sprite, clear the item type, and set the active container to no one. That's all that's needed. So the other thing is inside part item in the step, we actually need to make the item fall to the floor. That's what this is going to do. If there's a player, then if the Y of the item is less than the player's Y, just increase the item's Y by 8. That means it's going to fall within 8 pixels of the player's feet, so it's not all in the same place, which is good. Otherwise, if there's no player, then we're just going to make the object fall to the bottom of the room, just as like a placeholder code for that. And if we run the game, we should now be able to drop objects. So click on an item and drop it, and they just fall like this. You can imagine we just picked up an item from an inventory. We don't want it, so we just drop it like this, and it falls to our player's feet. Okay, so we're getting quite into it now. The next thing we're going to do is the ability to pick up objects from an inventory. So for this is going to be in the step of the container parent. Let me just zoom out, make it visible. So it's within active, just below our big region where we place an item. We're going to have one for picking them up. So it's not that big, it's not too much. So if this container is the active container, and there's no current mouse sprite, and the mouse is within the inventory, so within the bounds of the grid for this container, and we just pressed the mouse left button, we're going to get cell X and cell Y, again based on the mouse GUI coordinates and where the container is. Then we want to check to make sure cell X and cell Y is within the bounds of the grid. This will run if it's true. So then we want to get the item type, which is stored in, you can be any one of the cells, but I'm just going to pick the top left cell, which is this. And we're going to get the information from this list here. This kind of thing is new in 2.3, where you can just access a list from a grid without making it into a variable first. So then, as long as there's actually an item there, it's going to be greater than or equal to 0. So we have these two regions. So the first one is going to add the item to the mouse and set global variables. So this stuff here. We want to know whether the item was placed, rotated or not. That's what this is going to tell us. And we also want to know the index of the item as well. We're going to use that later on. So then we want to set the mouse sprite as to whatever the rotated sprite is for that item. We have it saved in our 2D array, if you remember. Then we want to update the global item type with the current item type for this item, and set global.rotated to rotated. Then in remove item from inventory, we're going to be using this variable index here. So zoom in. we're going to have a double for loop going for the width and the height of the grid. We're going to get a list from each cell of the grid. We're going to check to see if the index for this list is the same as the one that we just picked up. If it is, then we're going to use our reset data script to reset the data for that list. There's other ways to do it. This is the way that I decided to do it. And then if these coordinates here that are based on the mouse, if they're not within the grid, then we're going to use a message, cell coords out of range for pickup, and just display the cell X and cell Y. You don't have to do the show debugs. It's going to be useful to find mistakes though. And that's it. That's it for this region. And we don't have to do anything else. We can now test the game. We can run it. Press I to open, move it around somewhere. Pick up a shield, drop it, pick up a spear, drop it, a sword. And then if I click on any of these three, like the sword, we can place it again. Click and hold. Still respects. If I try and place it above an item, then it gets dropped like that. See, when it's red, I release it, it gets dropped. Awesome. So say for example, a player wants to get rid of items, all they have to do is this. It's that easy. Okay, so let's do rotation now. In the step of Obj main, we have a new region called rotate sprite. If we press R and there's actually a mouse sprite, then we're going to switch global rotated to either true or false. If it was true, it'll be false. If it was false, it'll be true. And then we want to update the mouse sprite as well. So either the rotated or not rotated version. And then we have a couple of safeguards as well. So if there's no active container, then we shouldn't be able to place an item anywhere. And also, if there is a mouse sprite, then we shouldn't be able to move anyone, basically. So if we run the game, we can test that working now. So open inventory, pick up a spear. If we press R, it switches. If we pick it up, it's at the same rotation, like that. It should work for every object. And the next thing we want to do is finally add a chest object. These are going to be like the containers you can find in the world. I've called it Obj chest, and I've given it the chest sprite for the room. We also want to make it a child of the container parent, so let's do that now. There we go. So it's inherited a lot of events, and then we want to create a create event, and inside it we're going to have this code here. We're going to inherit the code from the parent. We're going to set its con type as chest, and then we're going to set the display X and display Y as these coordinates, basically. And also put it in the room, might be useful. We plonk it there, that'll do. Let's run the game. I don't think we coded for opening it yet, did we? I don't think so. No, okay. So all it does for now is it just sits in the room and does nothing. So I think we'll tackle that next. Okay, 2.3 just did me over. But I think I fixed the problem. Basically, I had two objects. I had a copy of container parent, and the one that I was using, updating step by step. The step event got cleared for some reason. I didn't do anything. It's just I've had it happen before since 2.3. So things weren't working, and I figured out that was why. So I'm just using the original one now. But don't worry, I think I've figured out what we need to do or not. So the next step is we're going to have this chest opening when we right click or not. So if we go into the step of the container object, and so we have our if active equals true section here. Underneath there, we're going to have right click to activate or deactivate. It's going to be big enough. Let me just shove this over here. Okay, so if we press the right mouse button and it's not the player inventory, and the mouse is over the sprite that's in the room, we're talking about the actual chest, not the inventory of the chest. So if we right click on it, then it's going to switch between active and not active. There we go. So let's test this now. So let's right click on the chest and it opens the inventory. We can add stuff to it. We can open the player inventory and move things between them like that. This is how you kind of collect loot. You know, you open the chest and then, oh look, there's a spear inside it. Let's move the spear over here like that. That's how we're going to have loot. And then you can right click the chest and to open or close the inventory. And the last thing we need is we need our containers to actually spawn with items for the player to find. So how we're going to do this is in the create event of our parent container down here. So we're going to have a list for each container called contained items. This is going to be a list of items that it starts with, basically just a list of numbers. So as I say here, the way that I'm going to fill the list with items is in the room itself. I'm going to edit the creation code for the chest. You don't have to do it like that. You could do it any way you want, as long as this list gets filled before the step event, before this stuff's going to run, because we're going to have this new region here. We're going to add the contents of the list we're going to add the contents of the list to our containers grid. So let's do this now. You know what, I'm sorry. Let's just fill the list first so it makes sense. So in the room, I'm going to double click on the chest and then go into the creation code. And then here you can see I'm adding a sword and a shield to the list called contained items for this chest. So we're going to add these two items to the chest. So in the container parent, in the step, this region is going to do that for us. So if the size of the list is greater than 0, then we're going to do this. Shift over a bit. Okay, so we have a for loop going from 0 to the size of the list. We're going to grab what item it is, so 0, 1 or 2 for the shield, spear or sword. We want to, what the point of this loop is for, what we're doing is we're trying to find a spot inside our grid. So if I just go back to my little diagram. Okay, so we're basically looking for, can we place it here, 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 da, da, da. We're going to check all of the grid to see if we can place the item, and if we can, then it's going to get placed. It doesn't do anything more than that. So we need to know the width and height of this thing, which is going to be basically X cells and Y cells. That's what it's going to be for. We're going to initialize the cell X and cell Y at 0, and the item cell X end is going to be 0 plus whatever the cell width is. So in this example, it's going to be zeros here. So plus X cells is going to be 2. So that's going to be the end. this one, and then same for the y end. It's just 0 plus whatever this equals, which is 2 in our example. So the way that I'm going to check to see if a space is valid or not is I'm going to have a variable called wanted value, and if we have a 2x2 item like this, then it's going to be 2 times 2, which is 4, times minus 1. So we're going to be looking for a score of minus 4. And if you remember, the sprite value for an empty cell is minus 1. So that's why. And then we're going to update actual value by the sprite value. It seems a bit of a weird way to do it now that I'm talking about it, but it seemed to make sense at the time. It seemed to be one of the best ways I could think of to do it. So we need to check to see as well if the width and height of the item is too big for the container. So if the width of the item is greater than the width of the grid, or the height of the item is greater than the height of the grid, then we're just going to set actual value to wanted value. What's going to happen here is because we're setting wanted value to actual value, we're going to skip all of this stuff, all of the checks, so nothing happens basically for the item. So we've just done all of this, and now the last bit really is this region. So let's get this open now. Okay, so as long as actual value doesn't equal wanted value, we're going to set it to 0. We're going to update actual value by the value of the sprite. Like I said, we're looking to get a match between actual and wanted. This is going to happen for every cell of the item. So if we have it over here, then it means that these 4 cells are being checked to see if their sprite value is minus 1. If all 4 have minus 1, that's going to give us minus 4, which matches our wanted value. So if we have what we want, then this bit here is going to add the item to the grid. Let's zoom out a bit. There we go. That's easier to see. So if after this check we just did, if we have the value that we want, then it means we can place the item. So this double for loop is going to add the item to the grid. So again, just as I should probably have made a script, because all this is doing is the same as placing an item into the inventory with a, when you release the mouse, it's the same thing. So we're setting the top left cell to be the sprite of the item, so we can draw it, and the rest of them to a sprite value of minus 2, and updating the index, item type, and rotation there. After we've done this, we want to update total items because that's our unique reference number, remember? So we always have to increase that after we add an item. So this else statement, if we did this check over the 4 cells and actual value does not equal wanted value, then that means there's something blocking the way, like an item or something. So then we're going to do this. Okay, so what we have here is in this else statement, basically we didn't find a spare place to put the item in the check we just did. So we're going to shift the cells over. We're going to try and shift them over to the right first. So the very first check we do is here, then the next check we do is here, and then the next check we would do is here. When we get to this spot, we can't go right anymore. So we want to go down to the next row, and we want to reset the X coordinate, item cell X is going to get set back to 0, and then we're going to check here, and then here, and here, and then Y goes down and reset the X. We check here, here, here. So that's all that this block of code is doing, this stuff here. So if we failed, let's put a comment, we failed to find a spot for this item, as long as the end of the X, this bit here, as long as this isn't here, then shift it along one. Otherwise, reset the X and reset the end X. If the Y end is less than the height, so as long as it's here somewhere, then increase it by 1, increase the end by 1, reset the X, like I said. Otherwise, if the end Y is here, then we've checked everywhere, we've done it, and so we can just break out of the loop. So it just means we can't place the item in there, basically, and that's it. Hopefully I explained that okay. It's my second attempt. And the last thing we want to do that we haven't done today is we want to change the layer of the containers based on whether they are the active container or not. That's what this is about. So if I am the active container, my image index is going to be 1, which means we're going to look highlighted, and we're going to change, we're going to set layer ID as active container. Otherwise, our image is going to be darker, and we're going to set layer ID as containers. And basically after that, we just set our layer to layer ID. So it's either going to be active or just normal. And that's it. Thank you to the patrons for suggesting and voting this one. It was a fun problem to overcome. Thank you for watching. I will catch you next time. Bye for now.